SRS internal shaft repair system was invented by Scott Wilbur and has been engineered to get broken composite hockey sticks back in the game. It combines new shaft lock technology with a carbon fiber air core to create an internal composite repair that is lightweight yet incredibly strong. And because of the air core's versatile design, the system is compatible with all Palo composite sticks from junior to senior. The SRS internal shaft repair system has proven durability through various testing methods. The stick flexing machine is one piece of equipment that is used to put the SRS repair to the test. The goal through this process is to simulate the maximum stresses placed on the repair during play. Rest assured, the SRS internal shaft repair system has demonstrated impressive resilience, and it is used today by amateurs and professionals alike. Thank you for purchasing the SRS internal shaft repair system. We at Edgewater Industries appreciate your business and look forward to a successful future together. This instructional video will take you through the entire repair process, step by step. It explains how to set up and operate the tools and equipment, create an internal composite repair, and prepare the finished stick for the customer. It also contains instructions for removing the internal repair, if necessary. Please watch the instructional video in its entirety so you are familiar with all the procedures. Before operating the cutoff saw, rotary saw, or any other power tools used during the repair process, please be sure to read all documentation provided by the manufacturer. For your personal safety, always wear an OSHA-approved dust mask and safety goggles when cutting, grooving, or grinding during the SRS shaft repair process. Wear protective gloves when using the SRS epoxy to avoid contact with your skin. Loosen the bolt securing the fence. After the fence is loose, use the square to align the fence to the saw blade. This will ensure a true cut. Once square, retighten the fence bolts. This procedure is generally done when you first get the saw and will need to be checked each time you start a repair. Remove the attached handle. Unscrew the chuck and remove the 1/8 inch collet. Replace it with the 1/4 inch collet and replace the chuck. Next, insert the shaft lock grooving bit. Measure 1/4 inch between the chuck face and the first band of abrasive on the grooving bit. Then tighten the chuck. After removing the hockey stick clamp components from the box, install both threaded knobs. Position the hockey stick clamp post on the workbench surface and tighten securely. Then, simply slide the clamp body onto the post. The hockey stick clamp can also be positioned horizontally for your convenience, depending upon the operation. Another option is to mount the clamp below the workbench surface. This can be useful if the repair is low on the stick, or if the ceilings are low. Secure the hockey stick with the clamp in the horizontal position. Use a heat gun to heat the area around the plug or blade. Do not use a torch, as this can damage the stick. Gently pull to remove the plug from the shaft. Before cutting sticks, make certain that the fence is square. It is critical that you cut through the same side of both stick halves. Lay the stick on the workbench with the same side up before cutting. Place one half of the stick against the cut-off saw fence. Be sure that the stick is lying flat on the base of the saw before cutting. Tighten the cut-off saw fence securely. Cut the damaged material off from the shaft. Repeat this process for the second half of the stick. The cut-off saw should not be used to cut wooden plugs. This will plug the abrasive wheel and it will need replacing. Keep the damaged section of the shaft with the plug. You will need this later to measure the plug extension. Some sticks have a plastic lining on the inside of the shaft. Peel this lining away from the area before grooving. Secure one half of the stick. Make sure your rotary saw is set to operate at 18,000 to 23,000 RPMs. Do not exceed a setting of 3 on the Dremel Advantage. Engage the rotary saw and insert the bit inside the shaft opening. Use the face of the rotary saw chuck as a guide, pressing firmly against the rim of the shaft. Move it to the side and begin grooving the interior of the shaft, working slowly in a clockwise motion. Groove depth is controlled automatically by the smooth surfaces on both sides of the abrasion bands. Be sure that the grooves are cut cleanly and continuously around the inner circumference of the shaft. Never allow rotary saw to move in and out of the shaft while cutting the grooves. Inspect the grooves and repeat the process as necessary. After grooving is complete, inspect the bit for wear and damage. We recommend replacing the bit every 50 repairs. Remove fibers and burrs along the edges of the shaft to ensure a clean, true joint. This can be done using scissors or a sanding block. The seal keeps the SRS epoxy contained near the joint and prevents leakage beyond the repair. Being certain that the foam shaft seal is properly positioned, insert the shaft seal by hand into the non-pour end. In most applications, this will be the bottom half of the stick shaft. Using the shaft seal insertion tool, push the seal into the stick shaft the full length of the push rod until the tool handle touches the rim of the shaft. This ensures that the seal is set to the proper depth. Once in place, lightly tamp the foam shaft seal until it is flush to all sides and flat. Visually inspect to make sure it is tight to the walls of the shaft. If the plug becomes twisted or fails to seal completely, remove with needle nose pliers and discard. Use a new shaft seal for reinstallation. Before aligning the stick, reposition the hockey stick clamp vertically. Lock down the half that contains the shaft seal in the bottom position so that the repair seam is centered in the opening of the clamp. Match the surfaces of the two halves and lock down the stick in the top position. Joining ends should come together, leaving no gaps. Using the alignment guides, check the stick. When a stick is properly aligned, all 6 guide edges will be in contact with the stick shaft. It is also necessary to check the adjacent edges of the shaft to ensure proper alignment. Most often, the stick will need to be aligned. This requires shimming the clamp. There are 8 possible shimming points. While holding the alignment guide, move the shaft in the clamp until all surfaces are flat. Note where you will place the first shim. Remove the stick half that requires adjustment. Then, cut off a piece of tape and apply it to the clamp where an adjustment is needed. Make sure that the tape is straight on the inside of the clamp. This will keep the shaft from rocking in the clamp. Reposition the shaft in the clamp and recheck alignment. Repeat these steps to make the necessary shimming adjustments, being sure to check the shaft with the alignment guides during the process. In some cases, it may require several pieces of tape stacked on top of each other. If the repair seam is close to the blade, turn the blade in to get a flat surface to do the front alignment. If it is tapered, the side alignment will have gaps, and it will be necessary to visually center the lower shaft. Once the stick is properly aligned, remove the upper half of the shaft from the clamp. Elongate the carbon fiber air core by pulling on both ends. This will make it easier to slide the air core into position. Pinch one end of the air core and slide it down into the shaft until it stops against the shaft seal. Pinch the top end of the air core and slide the shaft down over it. Make sure that the grooved end of the shaft is placed over the top of the air core. Clamp down the top half of the shaft and make sure the graphics are properly positioned. Recheck the alignment. Cut a piece of the SRS stick sealing tape to a length of 4 to 5 inches. Wrap the tape gently and smoothly around the shaft seam, being sure not to wrinkle or stretch the tape. Once applied, smooth the tape to remove bubbles and creases. This will prevent the epoxy from leaking. Give particular attention to the area where the tape overlaps itself. Go through the following checklist to ensure that the stick has been properly prepared. Grooves have been cut into both halves of the shaft. The shaft seal is in the lower half of the hockey stick. The air core is also in position. the shaft is aligned with the graphics in their proper orientation, and the top half is clear of obstructions. After both the resin and hardener containers are opened, completely pour the hardener into the resin, allowing the hardener to drip until the entire contents have been expelled. Mix thoroughly for 60 seconds. It is important to scrape the bottom and side walls of the container while mixing. Stop and look at the mixture. Mixture should be perfectly clear with no swirls of unmixed resin. Mix an additional 30 seconds. Next, pour the epoxy into the top of the shaft. Try to pour directly down the center of the shaft without hitting the sidewalls. Allow container to drip into the shaft until all the epoxy has been poured out. Gently tap the shaft near the repair with the shaft seal insertion tool for approximately 10 seconds. This will release any air bubbles that may be trapped in the epoxy. The hockey stick clamp can be moved and placed on a curing rack. Make sure that the orientation of the clamp and stick stays the same. Do not rock or turn the clamp. This will free up the work area and allow you to start the next repair. After 8 to 24 hours, the stick can be removed from the clamp, but should not be returned to the customer until the repair has cured for a minimum of 96 hours, or 4 days. For maximum strength, allow the repair to cure for 6 days. It is critical that the shaft is not bent or flexed for 96 to 144 hours from the time the epoxy is poured. We recommend using our Grip-It wall-mounted curing clamps to keep the stick straight and out of harm's way. Room temperature during the curing process must be close to 72 degrees Fahrenheit. After the SRS epoxy is completely cured, install a plug extension in the end of the shaft to compensate for the length lost when removing the damaged area from the stick. Lay out the old plug with the removed, damaged section of the stick. This will give you an accurate measurement to cut the plug extension. The shaft must be flexed several times in all directions. The epoxy on the inside of the shaft will make cracking sounds during this process. These sounds are normal and allow the stick to return to a more normal flex pattern.